says we're live. Hang on. We want that. Yeah, there we go. Okay. Need that t-shirt. Wildly unprepared. My marker board thing isn't even plugged in. Should have probably waited 30 seconds to start the stream, but sometimes it takes it a second. Now I'm making all kinds of racket. There we go. Okay, so today I want to take a look at some circuits, like electronics circuits, and I want to do linear algebra. And I want to do that in reverse order, I think. And problem requests. If you have a request, let me know. I would be happy to work it for you. I don't know if YouTube chat will let us post pictures. Is that an option? Doesn't look like it. Yeah. So what I want to do is, if you have a problem that's difficult to put in as like a single line or two lines in the YouTube chat, pop over to the Discord and either post a picture of it or a more detailed explanation or something, so that I can see it and be able to work it properly. Link to the Discord is in the description. But for now, let's do some linear algebra. It's not hard. Normally you have two equations, right? Y equals mx plus b. Y equals ax plus c. Just as two examples. And we want to find where they intersect. So we plot them. We got one line here, and this point is where these two equations are equal. So if we want to find the intersection, normally what we're going to do is we're going to say mx plus b equals ax plus c. Then we'll combine like terms. So we have m times x minus a times x plus equals c minus b. And then we factor out over here, and we have x times m minus a equals c minus b. And then we divide. X equals c minus b divided by m minus a, as long as m and a are not equal. Because if m and a were equal, they would be parallel lines, and they wouldn't cross. So that gets us our x coordinate, and then if we want the y coordinate, we just do y equals a times c minus b over m minus a plus c. So then this point is c minus b over m minus a, comma, a times c minus b over m minus a plus c. And that's the point. Now, that didn't take long. It took maybe 2 or 3 minutes. And realistically, I would have gotten it done faster if I wasn't saying it as I was doing it. But there is a better way once you learn it. It is faster, and that is to use linear algebra. It's faster with an asterisk. It's a lot faster with a calculator. If you're not used to doing it, it's probably slower without the calculator for 2 equations, but when you get up to more equations, it's still faster because it's just less to keep track of. So one of the nice things that we can do with matrices is we can set them up to solve systems of equations, just like this. So this is a system of equations. It is very hard to write sideways on a drawing tablet. And if we want to translate this into the matrix world, we'll do the matrices in yellow. Then what we're going to do is we're going to say we have one big equation where we have y equals y? No. We'll do this. We're going to do m here and b here. I think I'm doing this right. It's been a while. Let's see. Not quite. We're going to rearrange these equations so that they match what I'm remembering. We want it to equal 0. So we're going to have m, or not 0, but a constant, not a variable. So intermediate step, we're going to do y minus m times x equals b, and y equals a times x. No, not equals, a minus equals c. And now we can set it up in a matrix. So we have y, or 1 negative m and 1 negative a times x, y, x equals b, c. Because now if we do this matrix multiplication, then we have 1y minus m times x. That's this row times the column. And then we have 1y minus a times x is the second element equals b, c. So that's a parenthetical note. I'm going to get rid of it. Now, that's not what I want this one. Yeah. now what I want to do is first fix that A so that you can tell it's an A. Is rewrite this in a way that's easier to solve. Because we can do it this way, and I will show you how to do it this way, but there's a quicker way that I want you to see first. And that is to use a technique called the augmented matrix and row reduced echelon form. So what we're going to do is we're going to say, this is our label. Label. And we're going to say, and then we're going to create our matrix to reduce. So we'll do 1, negative m, b, 1, negative a, c. And our goal is to get it into the form 1, 0, 0, 1 with something here and something here. And we don't care what it is, except that this is our actually going to be our answer. This will be y, and that will be x. Now, to do that, there are a specific set of rules that we have to follow. We can swap these rows if we want to, back and forth. And I should say here, the rules row swapping is okay. Multiplying by a scalar multiplying a row by a scalar. A row by a scalar is okay. Adding rows is okay. And lastly, combining 2 and 3 is okay. Besides that, we shouldn't need to do anything. So if we want to get this, or this mess, into this form, what we're going to do is we're going to start with this matrix, and I'm going to walk you through the process. We have 1 minus m b. And the first thing we want to do, well, let me start over. We only want to change one row at a time, just for clarity's sake. So the first thing we want to do is we want to get this to say 1, 0. And so what we're going to do is we're going to say row 1, plus negative m, nope, yeah, negative m divided by negative a times row 2. So we're going to take row 1, add m over a times row 2 and put it into row 1. So that's actually not going to be 1. So row 1, this value is going to be 1 plus m is this correct? Yes it is. And then it's going to be m over a times 1, because we're going to take this value, plug it in there, and then this whole thing applies to get this element. So that gives us 1 plus m over a. And so we have 1 plus m over a for just that first element. Now we do this one. And for this, we're going to do row 1, so that value is negative m, plus m over a times row 2, which is negative a. And so when we do that, we cancel those values out. We have a negative. Whoops, this should be a minus. And I don't have to change my statement over here because adding and subtracting are the same operation, just in opposite directions. So we'll cancel that. Yeah, let's go back to yellow. Cancel that A and that A. Replace this with the correct sign. And so that goes to 1, which leaves us with m. Nope, I had it right. What am I? Yeah, because we have this negative sign here that doesn't go away. Turns that into a plus. And so that's a 0, which is what it should be. And then we're going to take this, and we're going to do this one. So this value was b, so take b, subtract m over a times c. Well, it doesn't get much better than that. C times m over a. We could simplify that, I guess. Probably not. We'll leave it like that for now. Okay, so now we have our new state of the matrix. Not state of the union, state of the matrix. So we have 1 plus m divided by a. We have 0. We have a b minus c times m over a. And I promise you this is easier long term. Let me just show you. One negative a c. So that's our whole matrix. And now we want to get a 1 here. Right? So what we're going to do, wait a minute. Yeah. What's the better way to do this? No, this is the good way to do this. Row 1 is going to have row 1 times 1 divided by 1 plus m over a, because we want this value to be 1, we're going to plug this number in here. So now we can do the new state of the matrix, which will be 1, because this divided by itself is just 1. 0 divided by that is still 0. And now all we have to really compute is b minus c times m divided by a times 1 plus m over a. So we have b plus b times m over a minus c times m over a minus c times m squared over a squared. This is getting ugly. So we have b plus m times b minus c over a So that's our new matrix, which is looking ugly, and I'm just showing you the long way to do it. There is a payoff to all of this work. And I'm telling you this because when I took this class, a lot of my classmates were going, "Why are we doing this? This seems like a lot more work than just solving the problem." And it kind of is. So now we're going to do row 2 is going to be made equal to row 2 minus row 1. So we have 1, 0, b plus m, b minus c over a minus c times m squared over a squared. 1 minus 1 is 0. Negative a minus 0 is negative a. And then we're going to have c minus b minus m times b minus c over a plus c times m squared over a squared. Last thing we're going to do is divide by negative a. Something is seeming really off here. I don't know why. Last thing, row 2 is going to be negative a. Yeah, r2 times 1 divided by negative a. 1, 0, b plus m times b minus c over a this is going to be c over a negative plus b over a minus m times b minus c. Why is this so goofy? If it's not readily apparent, this is not what I expected to get out of this. Let me see if I can simplify this down. B plus m times b minus c over a squared a times b over a minus c times m squared over times a divided by a squared nope not what I'm wanting. Plus m times b minus m times c divided by a m times c over a. So I've just regrouped so that this has become a group and that's become a group. Minus c times m squared over a squared. So then we have b times a plus m over a minus m over a times c minus c times m c times m times 1 minus 1 over a This is not going anywhere. If somebody sees what I'm doing, or have done, please say something. I'm not above being corrected. A over A minus 1 over A. C times M over A minus 1 over A. I need my fancy calculator. Do I have? Do I not already have this? I do not already have this. It's not. Huh. I am apparently not equipped because I didn't already have this tool installed. Come on. Oh. Okay. Hang on a second. I've got my tool. I want to enter my thingy. If I do M equals come back over here. I'm having to relearn this tool because it's been a while since I've used it. One minus M B 1 negative A C What do you mean? It does not do it. Alright, let's do it with Python. New window. There we go. Import. Oh, let me bring it up so you can see what I'm doing. I gotta. Oh, yeah, it's visible. Cool. That's the wrong PyCharm. Why is edge up? I don't want edge. I want this one. There we go. I'm going to import SymPy. Except I don't have SymPy. Install SymPy. I don't know why it's over there. There we go. SP dot. Here we go. I need to create variables, so I'm going to do M, A, do them alphabetical order, A, B, C, M equals SymPy dot symbols A, B, C, M. If I run that, I shouldn't crash. Should be fine. Yep. Didn't do anything, but that's fine. Now, I want to create my matrix. So capital M for matrix equals SP dot matrix. This one's going to be 1, negative M, B, and then one B, negative A, C, and then can I SP dot RRE F? Oh. RREF, row reduced echelon form, is a really unstable way to do what I'm trying to do on the computer. So SymPy does not have that built in. There are better ways to do it on the computer. For doing it by hand, it's fine, because you can keep track of those things. Where I don't have I'm attempting to get the emulator for my Inspire, TI Inspire CAS. If I was a little better prepared, I would have it ready already. But I do not. Well, I'll show you the other way to do it while it's downloading. New page. The other way to do it, that's objectively simpler. I just wanted you to see this full method, is to use the matrix like we came up with in the first place, very first place. This is, well, not the very first. 1, negative M, 1, negative A, times X, nope, times Y, X equals BC. Now, to do this, we want to move this thing to this side so that we can solve for y and x, because we know how to do matrix multiplication. The problem is you can't just divide by a matrix. you have to take the inverse matrix. Which is why sometimes I kind of wish that in school, when they're teaching you how to solve algebra problems, that they would teach you to write this way, you know. Teach you to write 3 to the negative 1 times. Move. Because that's essentially what we're doing here, is we have m times vector y x equals b c, and what we want to end up with is y x equals m inverse times b c, because m inverse times m equals 0, or 0. Blah. No, it doesn't. It equals m inverse times m equals the identity matrix, which is equal to 1, 1, 1, all the way down. Right? So for this guy, we're gonna want to end up with 1, 1, 0, 0, y x equals something times b c. That's done. Yes, please. Next. This install. So the thing here is, in order to get this matrix without a calculator, you have to use the row reduced echelon form. It is what it is. I said that. There's 2 ways to do it. Okay. Does it just work? Do I have to activate it? I do somewhere, but I have to find the book. Aha! It may be working here in a second. Hey! Stop it. Okay. Oh, this has been updated since the last time I used it. I need to add a source so that you can see window source, window capture. Inspire cast source. Where did you go? There it is. Hey, there it is. Okay, we're gonna add the calculator. We're gonna say it's been a minute. It's a 2 by number of columns 4. All right. So what we want here is we want to start with 1 negative m and 1 negative a, and to find the inverse, this is for the inverse one, we want to end up with 1, 1, like that, right? So we're going to do RREF, row reduced echelon form, and it gives us this, which I can. Let's make this smaller, move it down here, and switch. Oh, I did all that with the thingy showing, and that's not what I wanted, and shame on me. I want this to shrink a little. I'm so sorry. What I was saying was, I wish they would show this in school. Can I maybe use this thingy? This, I wish they would show it this way in school, at least a little. That way you get used to seeing it that way. Because we end up having to solve the equation this way. And instead of 3 inverse times 3 being equal to 1, it's the matrix equivalent to 1, which is just the identity matrix. So here we'll have 1, 0, 0, 1 for our m inverse times m. And the m inverse will go here, which we can then multiply by this guy to get this vector. Now, in the calculator window thingy down there, you can see my window thingy not working. You can see here what the inverse matrix ends up being. I can show you and prove it. Not quite. Let's do it this way. 2, 2. Right here. 2 by 2. 1, negative m. 1, negative a. Can I do that? Yes, I can. And you can see that this ends up being the same as this part of the matrix. But that doesn't help you get it by hand. And I want you to see where it comes from. I don't want you to just know how to do it or what it is. So let's take a look. That's the form we're working to. In order to set it up, we're going to do 1, negative m, 1, negative a, 1, 0, 0, 1. We want it to get it. We want to turn this into this. And we're going to do it by saying row 1 nope. We're going to do it different. Row 2 minus row 1. Put that back into row 2. Now we have 1 minus 1. One minus 1 is 0. Negative a minus negative m is negative a minus m plus m. 1 minus 0, 0 minus 1 is negative 1. 1 minus 0 is 1. Now I can divide by a plus m, or negative a plus m. We'll do row 2 gets to be row 2 times m minus a, 1 over m minus a. We have 1, we have negative m. This is probably the way I should have done the other one, because the other one got way ugly, way fast. This will be 1 as long as m minus a is not 0. And this will be, yeah, -1 over m minus a. I'll fix the negatives here in a second. And this will be 1 over m minus a. R2 is now done. Now all we got to do is R1 equals R1 plus m times R2. So we have 1 plus m times 0 is 1. Negative m plus m times 1 is 0. 1 plus m times this is negative m over m a minus m, come on. And then 0 plus m times this is m times that. 0, 1, 1 over a minus m, 1 over m minus a. And if we look at our thing, it matches, doesn't it? Maybe not. Yeah, it matches. I had to put the 1 because I forgot to add the 1. But this is how you find the inverse. There's a way to find the inverse. I believe there's another way using the determinant. So 1. This will be a side note. If we have A, B, C, D, and we want the inverse, it's going to be we need the determinant. So A, B, C, D equals A times D minus B times C. Yeah. I believe that's correct. Let me double check so I'm not lying to you. Yep, I told you correctly. Very good. Makes me happy. AD minus BC. And if we want the inverse, that will be the determinant. So A times D minus B times C. 1 divided by the determinant times the matrix D negative B negative C A, I believe, which is what we see. I think. Again, let me double check. Yeah, that's correct. So we didn't have to go through all of these steps to find it. We could have just said that Yeah. One negative m, one negative a. I'm writing crooked. I have to call it. I think I'm losing my mind or something. Inverse equals, what's the determinant? I am losing my mind. Equals negative a minus negative m equals a plus m. Nope. Negative a plus m. So then the determinant is 1 over m minus a times negative a m negative 1 1. And when we distribute in, we end up with negative a over m minus a m over m minus a 1 over negative 1 over m minus a, which is the same as 1 over a minus m, and 1 over m minus a. Now this is the only one that you might be questioning. Be like, hey, I thought you said they were the same, and they are. If we do 1 plus m over a minus m, we put a common denominator on it, so we have a minus m over a minus m plus m over a minus m. Then we really have a minus m plus m over a minus m. Those go away. You're left with a over a minus m, which matches. So they are the same. I hope you are convinced. Yeah, so once we have that matrix, I don't know what went on up here. Something went afoul. Yeah, something went afoul and we did not do that right. I will revisit that another time. But now we know what goes in these blanks. And that would be a over m minus a. M minus a minus m. This one will be m over m minus a. This one is 1 over a minus m. This one is 1 over m minus a. And so if we copy all of this, select it all again. I don't need this guy. then we can say y colors y x equals, and then we will distribute b times a over a minus m plus c times m over m minus a, and b over a minus m plus 1 over m minus a equals, now I'm going to start combining things, a times b over a minus m minus c times m over a minus m. That way they match. And that should be a C. B over a minus m plus c over m minus a minus c over a minus m equals a times b minus c times m over a minus m and b minus c over a minus m, which, if we look back here at the original solution, is what we see, right? Nope. I don't know if it's going to let me copy and paste between pages. It did. Move you all of that. Could have written it out by this time. Boom. Boom. And so that equals x and that equals y. If we simplify this out, a times b minus c times m over a minus m. How can we simplify that? Equals c minus b, nope. Can I do c times m minus a times b divided by m minus a. So now at least I have them in the same kind of order there. Unless I made a mistake somewhere. minus b. Let's start from a different place. Instead of starting from that one, let's start from the other one. A times c minus b over m minus a plus c equals a times c minus b times, or minus a times b minus a plus c times m minus a over m minus a. Yeah, should be fine. A times c minus a times b plus c times m minus a times c over m minus a. We have an a times c and a negative a times c. We got c times m minus a times b over m minus a. Equals a times b minus c times m over a minus m. Yeah. And this are the same. And this and that are the same. So these two methods are equivalent. But your calculator can do a lot of these automatically. So if you come to the calculator, and let's make this bigger, boink. I don't want to cover my face. There we go. What we can do here is set this up to be completely solved by the calculator. Stop it. I don't want a 9 there. We want 3 by 2. We're going to do 1 negative m b 1 negative a c. Row reduced echelon form. Boom. And that's yet another way to write the same thing that we've written. So I hope that you will take my word for it that this is correct. And we can use this one thing in the calculator to solve a system of equations. Nice thing is this scales up. So we did 2 equations, but if we had 3 equations, we could easily make it bigger and bigger and bigger and bigger for as many equations as we have, which is handy when we start solving circuits. Unfortunately, this took me way longer to get through than I anticipated, so we don't have time to go through circuits today, and I didn't see any requests pop up in any of my chat streams, so I think we are going to call it for now, and I will see you guys next week. So if you have liked this at all, if this has been interesting or entertaining or helpful, be sure to hit the like button, subscribe, join the Discord, leave your comment or leave your problem requests in the Discord so that I can get to them for next stream. And I will see you guys next time.